All right, we've got a question here about internal energy and total intermolecular potential energy. And notice here we're going from a liquid into a solid. What we want to do is determine which one's changing and how. As ever, hit pause, try the question, and when you're ready to see an explanation, press play. Okay, so we've got a different kind of question here. We usually think about gases here, but this time we're looking at solids and liquids. I think to start us off, we're going to think about what internal energy is. In internal energy, we're looking really at two things. It's the sum of the randomly distributed, that's always key in a definition, potential and kinetic energies. Now, if we're changing potential energy, which is what we're looking at here, change in potential energy, we need to know about the change in the potential and the change in the kinetic. Now, we're told in the question that the temperature is constant. Now, temperature, as you'll be aware, drives kinetic energy, and so therefore, higher temperature, higher kinetic. If the temperature is the same, the kinetic energy is also the same. No change, delta Ek is equal to 0. What this really means, okay, is that, well, so before we go on to talk about that, what this means, if we get rid of this, whatever U is doing, EP is doing. Or to put it a different way, whatever EP does, U does. So actually, we're looking, I think, unless I've forgotten something, for an answer which has the same in each table. So we're looking at either A or D here. Whatever delta EP does, delta U is going to do the same. Let's think about this. We're looking from liquid to solid, and so therefore our particles are getting closer together. And what this means is they have a lower internal energy or a lower potential energy, okay? Which means, I've kind of jumped the gun a little bit here, whatever our delta U does, delta EP does, which means they're going to do the same, right? So by losing our energy, right, losing our internal energy, our potential energy must also decrease. And the reason it decreases is because those particles get closer together. We decrease their molecular separation, and that's why the potential energy is also decreasing. That's why the answer here is A.